Welcome back to the Daily News Update. I'm Oliver, and I'm joined by Jane today. We've got 9 major stories coming out of June 24th, 2026, and honestly, today feels like one of those watershed moments in AI. We're seeing a collision between 3 different forces, governments finally waking up to the need for AI regulation, some pretty alarming security vulnerabilities in tools that companies are betting their futures on, and simultaneously, a wave of new infrastructure that's trying to democratize AI instead of concentrating it further.
Exactly. And what I find fascinating is how all of this is happening at the same time. You've got Anthropic, which is literally one of the safety-focused companies, getting caught with encrypted reasoning blocks that hide what their models are actually doing. Meanwhile, they're also launching Claude Tag, which is this ambitious bet that AI should be embedded right into how teams collaborate. So it's like, yes, here are powerful new tools, but are we really ready for them?
That's the tension running through today. We're also seeing Meta double down on consumer hardware, glasses, headsets, all with AI baked in. And the UK government is saying, okay, we're not going to try to outcompute Silicon Valley, but we're going to invest £60 million into making AI cheaper and more accessible. So the message is clear. AI isn't slowing down. The question is, who controls it and how?
Right, and for builders and teams actually trying to ship things, there's also a lot of practical innovation. We're going to talk about orchestration frameworks that let you run multiple AI agents in parallel, agents that can actually improve their own instructions, new thinking about how to structure work around AI loops instead of one-off prompts. It's not all warnings. There's real opportunity here too.
So, if you're interested in where AI regulation is heading, what security risks you should actually worry about, how the enterprise collaboration layer is being contested, or what open source alternatives to the big model providers might look like, stick around. We've got a lot to cover today. Let's start with something that feels like a warning bell. Chris Olah, co-founder of Anthropic, just told the Vatican something pretty stark. AI companies cannot be trusted to govern themselves on the profound moral choices now embedded in their systems. We're talking about border control decisions, mortgage approvals, weapons targeting. These used to be human choices. Now they're baked into algorithms.
That's a significant statement coming from inside Anthropic, which is supposed to be the safety-conscious company. What's his argument for why self-governance doesn't work?
It goes deeper than just trust us. The article describes something called an economy of virtue, where AI companies are essentially manufacturing ethical credentials to fend off regulation rather than making real changes. And here's where it gets darker. Companies are doing these public participation exercises, asking citizens what they think about AI ethics, collecting feedback, then nothing changes. The author calls this participation washing.
Okay, but I want to probe that claim. Is participation washing really as widespread as the article suggests? Are we talking about most companies, or is this isolated to a few bad actors?
The article specifically mentions Anthropic's own collective constitutional AI project as an example. The pattern is consistent. These participation experiments arrive late in the process, ask narrow questions, and grant no actual decision-making power. So you're not democratizing the choice. You're getting the appearance of democracy while the company moves forward with whatever it planned anyway.
So, what's the alternative? The article proposes something specific, right?
Yes, it looks to precedent, drug approval, and nuclear power oversight. In those domains, an independent regulator has the actual authority to say no. They can refuse approval. They're informed by public moral standards about what levels of harm are acceptable. That model would mean AI decisions about borders, mortgages, weapons. Those wouldn't be corporate choices. They'd be decisions made in the public sphere, informed by technical experts but controlled by an independent body.
That sounds clean in theory, but here's the practical question. Can democracies actually move fast enough? The FDA takes years to approve a drug. AI is moving in months. How do you build a regulatory framework that doesn't become instantly obsolete?
That's exactly the crux of it. The article acknowledges this. Democracies need to move these choices into public hands before AI moves too fast to regulate. It's a race, and right now, AI is winning the race. You've got 3 or 4 companies controlling frontier models, they're embedding moral decisions in their systems, and by the time regulators figure out what questions to ask, the infrastructure is already baked in.
And there's a concentration problem layered on top of that. If the moral framework for AI gets set by whoever controls the models, OpenAI, Anthropic, Google, then you're not really setting policy through democratic process. You're just hoping those companies make good choices.
Which brings us to the central question the article poses. Can democracies move fast enough to set moral standards before AI moves beyond regulation? Because if the answer is no, then you're left with a world where decisions about who gets a mortgage, who gets targeted by a weapon, who gets detained at a border, those are made by algorithms designed by companies answerable primarily to shareholders, not citizens.
Okay, we need to talk about something that's genuinely alarming. Anthropic just got caught with what I'd call a cryptographic time bomb buried in Claude code. The feature is called extended thinking, right? And it's supposed to give you visibility into how the model is reasoning through complex problems. You turn it on, and in theory, you get to see the actual thinking traces. Except, it doesn't actually work that way.
What do you mean it doesn't work that way? What's actually happening?
Instead of returning real reasoning traces, Claude code returns encrypted summaries. And here's the kicker. There was a silent default change that reduced the depth by 67%. So you're not even getting a full encrypted summary, you're getting a stripped-down version, and you don't know it. The opacity is baked in.
Silent default changes to something users are relying on for transparency? That's not great. But let's go deeper. I read that cryptographer Matt Green found something even more concerning about the encryption itself.
Yes. So Green did a cryptographic analysis of how Anthropic and OpenAI are encrypting these reasoning blocks. And the discovery is bad. Both companies are using a single global encryption key, not per account keys, not per session keys, one key for everything. Which means, in theory, if you have access to encrypted reasoning blocks from one account, you could potentially decrypt reasoning blocks from other accounts.
Wait, that's a cross-account replay attack vulnerability. So if I'm a malicious actor with access to any encrypted reasoning block, I could potentially extract proprietary information from anyone else using the system?
Exactly. And it gets worse because it's not just about having the key. Green also found side-channel vulnerabilities. You can extract information from reasoning blocks just by analyzing response timing or the length of the encrypted block itself. You don't even need to decrypt it. The metadata leaks information.
So if your company is using Claude code to work on proprietary algorithms or trade secrets, and that reasoning process gets logged as encrypted blocks, someone could potentially infer what you're working on just from how long the reasoning took or how large the encrypted summary is?
That's the practical implication, yes. And it's not theoretical. This is actual cryptographic analysis. If you're a financial firm using Claude to develop trading algorithms, or a biotech company working on drug discovery, or a defense contractor, the extended thinking feature that you thought was giving you control over transparency is actually a liability. You're creating encrypted artifacts that could leak information through side channels.
This connects directly back to what we were just discussing with Anthropic and self-governance. Chris Oller says AI companies can't be trusted to regulate their own moral choices. But maybe the more immediate issue is that they can't even be trusted to implement basic cryptographic security. Is this negligence, or is this deliberately obscuring what the models are doing?
That's the question everyone's asking. The silent default change, that 67% depth reduction, suggests it wasn't an accident. But I want to be fair. The encryption vulnerability with global keys could be a scaling decision gone wrong rather than intentional. Still, the fact that these security flaws went undetected long enough for an independent cryptographer to discover them publicly, that says something about how these systems are being audited or not being audited.
So we've got a situation where companies are racing to deploy powerful AI tools into enterprises. Claude Code is being used for actual software development, actual reasoning on real problems, but the infrastructure underneath has these fundamental cryptographic holes. How does that get fixed?
That's the practical question. Per account encryption keys instead of global keys would be a start. Proper security audits before shipping features. Transparency about what extended thinking actually returns versus what it claims to return. But the underlying issue is the speed. These tools are being shipped faster than they're being hardened, and for companies building on top of them, that's a real risk calculation.
So speaking of tools being deployed into enterprises before they're fully baked, Anthropic just made a pretty bold move. They're replacing their Slack app with something called Claude Tag. And this isn't just a chatbot upgrade. This is a fundamental shift in how they think about AI in the workplace.
Okay, I'm intrigued. What does replacing look like? What was the old Slack app doing? And what's different about Claude Tag?
The old Slack integration was basically what you'd expect. You'd ask the bot a question, it'd answer you, and that was it. Each person had their own instance of Claude running separately. Claude Tag flips that model entirely. Instead, you get one persistent Claude agent per channel that serves all team members. It has channel-specific memory. It works asynchronously on multi-hour projects, and it can take proactive initiative. It's not just waiting for you to ask it questions.
Wait, so it's a shared team member. One AI per channel, not one per person. That means if I'm working on something and I hand off to a colleague, Claude already has the context from our entire conversation history?
Exactly. It's multiplayer by design. And here's the part that shows how confident Anthropic is in this. They're claiming that 65% of their own product team's code now flows through Claude Tag. This isn't an experimental feature they're offering to customers. This is their infrastructure. They're dogfooding it at scale.
65% is significant. That means Claude Tag is doing actual production work on actual Anthropic products. But let me ask the obvious question. If Claude Code just got caught with encryption vulnerabilities and hidden depth reductions, how much should we trust that Claude Tag is actually working as advertised at scale?
That's the tension I'm sitting with too. But let's give them credit for the architectural innovation here. Claude Tag also comes with what they're calling an enterprise governance model. Administrators can define separate Claude identities per use case, scoped to specific channels with specific tool access, data access controls, token spend limits, and complete audit logs for compliance. So there's at least a framework for managing risk.
Okay, so it's not just dump AI into Slack and hope for the best. There's governance around it. But here's what I'm more curious about. You mentioned this as the third evolution of LLM interfaces. What does that mean?
Right. So, the analyst Andrei Karpathy has been thinking about this. The first evolution was web chat interfaces, ChatGPT, Claude.ai, that sort of thing. You go to a website, ask a question, get an answer. The second evolution was desktop apps that maintain some kind of persistent context. Cursor, Copilot, running as a development assistant. Claude Tag represents the third evolution, embedded organizational systems. AI isn't a tool you go visit. It's a team member that lives in your collaboration layer, the place where work actually happens.
And that matters, because Slack is where decisions get made. It's where context lives. It's where handoffs happen. If you embed AI there, you're not just adding another tool, you're inserting it into the central nervous system of how teams operate.
Exactly. And that's why Slack has become the battleground for enterprise AI right now. You've got Salesforce trying to integrate AI into Slack itself. You've got OpenAI building workspace agents. Perplexity is making a move. Cognition's Devon is trying to be the AI developer working directly in your codebase and your collaboration channels. Microsoft Copilot is in Office and Teams. Everyone is racing to own the collaboration layer.
So Claude Tag isn't just a product feature, it's Anthropic saying, we're competing for control of how work gets done. Which raises a pretty uncomfortable question. Is this the future of work, or is this a technology company trying to own the entire business operating system?
That's the right tension to feel. On one hand, if Claude Tag genuinely makes teams more productive by handling coordination work and delegation at scale, that's probably good for people using it. On the other hand, you're becoming more dependent on Anthropic. Your team memory lives in their system. Your audit logs are their audit logs. The governance model they define is the governance you get.
And given what we just discussed about encryption vulnerabilities and silent default changes in their other products, the question is, how much can you actually trust that system? You're embedding this deeply into your operations, and you're taking it on faith that the security and transparency claims are accurate.
Which loops back to the regulation question from our first segment. Claude Tag is exactly the kind of system that needs independent oversight. It's making decisions about how work gets prioritized, what gets escalated, what gets logged. Those are governance decisions embedded in a tool that one company controls.
And Anthropic is explicitly marketing this as the future of team coordination. They've got the credibility as a safety-focused company, but that credibility is getting tested by the technical issues we've found in their other products. So enterprises looking at Claude Tag need to ask, is this genuinely safe and trustworthy infrastructure, or is it the flashiest play to lock in market share before anyone else can? So we've been talking about all these powerful new tools, Claude Tag, orchestration frameworks. But here's a practical problem most developers face. The landscape is moving so fast that by the time you evaluate what's available, 3 new categories have emerged. There's a GitHub repository called Awesome AI Coding Tools, maintained by AI for Developers, that's trying to solve that. It's basically a curated map of everything that exists right now in the AI development space.
A curated list sounds straightforward enough, but when you say the landscape is moving fast, what does that actually mean? How quickly are new categories of tools emerging?
Fast enough that the repository itself reflects shifting categories. You've got the established stuff, GitHub Copilot and its ecosystem with coding agents, model selection, session management. But then there are newer categories that didn't exist even 6 months ago. Model Context Protocol, which is how tools share context with models. Agentic workflows, where the AI is orchestrating work across multiple steps. Automated code review, SleftyTwit agents, software engineering agents that can work autonomously on code bases. These aren't incremental features, they're new problem classes that tools are building around.
So the repository isn't just cataloging tools, it's mapping the shape of what's possible. But here's what I'm curious about. Who actually uses something like this? Is this a resource for tool builders trying to figure out what gaps exist? Or is it for developers trying to figure out what to build with?
Both, honestly. But the practical use case that matters most right now is the second one. Solo developers and small teams who need to make tool selection decisions fast. If you're a solo builder shipping multiple AI-assisted products, which by the way seems to be an emerging pattern, you can't afford to spend weeks evaluating every option. You need a current map of what exists, what each tool does, what categories matter. This repository gives you that without having to reverse engineer it from Twitter threads and conference talks.
And that's actually connected to something we touched on earlier, the portfolio approach. If you're launching multiple small AI businesses in parallel, you need to make informed tool selection decisions without getting bogged down in research. What does informed even look like in a landscape moving this fast?
It means knowing which categories of tools exist, so you're not reinventing evaluation each time, and having current snapshots of the active options in each category. Is Copilot the right choice for this use case, or should you be looking at a coding agent or something built on the Model Context Protocol? The repository lets you quickly answer that question instead of starting from scratch, and it's actively maintained, so as new features land in the Copilot ecosystem or new categories emerge, the reference point gets updated.
So this is really about reducing friction in the launch cycle. You want to move fast from idea to deployment, and part of moving fast is not spending 6 weeks figuring out what infrastructure to build on. A maintained reference that maps the landscape every few weeks actually changes what's possible for small teams.
Exactly. And when you layer that on top of everything we've talked about today, Claude Tag for team collaboration, orchestration frameworks for running multiple agents, self-improving harnesses, you start to see an ecosystem emerging where solo builders can actually do what used to require teams. The constraint becomes your judgment and time, not the availability of tools.
All right, so we've talked about tools like Claude Tag that help teams coordinate work. But if you're actually running multiple AI agents in parallel on the same code base, and this is increasingly the reality for teams deploying AI, you need orchestration that doesn't fall apart. There's a framework called glueRun-go that's building exactly that. It's Bash and Python orchestration designed to drive autonomous AI coding agents in parallel without chaos.
Okay, when you say without chaos, what's the failure mode you're preventing? What goes wrong if you just point multiple AI agents at the same repository?
You get race conditions, conflicting changes, agents stepping on each other's work. So glueRun-go uses a 3-tier scheduling model to prevent that. At the bottom, you've got L0, an origin scheduler that runs reconciliation cycles. That scheduler creates batches of work for L1, which are area planners. The area planners then spawn L2 worker agents that execute in isolated Git work trees. So each agent gets its own sandbox, they can't interfere with each other.
Wait, so the isolation is the key piece. Each agent is working on its own copy of the codebase in its own work tree, which means they can't corrupt shared state or overwrite each other's work. But then how do changes get integrated back?
That's where the lease management and state packets come in. Each worker agent owns a lease, essentially a lock that says this work is mine for this time period. The agent does its work in the isolated work tree, outputs a state packet that enumerates what files changed, what commands ran, what tests passed or failed. Then there's a gate pipeline with auditing. The auditor model evaluates the work, and a decider determines what to do next: retry, amend scope, escalate, or park the task.
So the auditor and decider are essentially quality gates. The agent proposes changes, but it doesn't just merge them into main. Someone or something actually reviews what happened and decides if it's safe to integrate. That's actually pretty responsible design, given how much damage an uncontrolled AI agent could do to a codebase.
Exactly. And here's another piece I find elegant. glueRun-go uses what they call detached dispatch by default. The L0 scheduler doesn't wait for workers to finish. It pre-leases frontier tasks, spawns workers in separate sessions, and returns within seconds. The workers run asynchronously, and the scheduler picks up the results on the next reconciliation cycle. So you get parallelism without blocking.
That's a smart operational pattern. You're not sitting around waiting for one agent to finish before starting the next batch of work. But now I'm curious about something different. We've got orchestration for running multiple agents in parallel. But what if the agents themselves could improve how they operate? That's another shift we're seeing in the research.
You mean the self-harness framework from Shanghai AI Lab?
Yes. This is a paradigm where LLM agents don't just execute their harness. The system prompts, tools, memory policies, all the scaffolding around the model. They actually analyze their own execution traces and rewrite their own rules to fix model-specific weaknesses. It's fundamentally different from traditional prompt engineering.
So instead of a human looking at failures and saying, I think the agent needs a better loop-breaking strategy, the agent itself mines its failure patterns, proposes harness modifications, and validates them through regression testing.
Exactly. And the results are significant. They achieved 33 to 60% performance improvements across multiple models, Minimax, Qwen, GLM, without human intervention and without relying on stronger external models to do the tuning. The agents essentially got better at operating themselves.
That's genuinely impressive as a capability. But I want to ask the question I think you're dancing around. If agents start systematically improving their own operating rules, rewriting their own harnesses based on failure analysis, doesn't that create an opacity problem? At some point, the rules are no longer ones that humans wrote or can easily understand?
That's exactly the tension. You've got a feedback loop where the agent's behavior and the system prompts and tools evolve together based on execution traces. That might make the system more capable, but it also means the agent's behavior becomes less interpretable. You can trace what it's doing in the moment, but understanding why it evolved that way becomes harder.
So you're describing a scenario where we build orchestration systems that run multiple AI agents in parallel, and those agents are themselves rewriting their own rules to get better at their jobs. At scale, what does that even mean for human oversight?
It means you need the audit gates and governance layers we talked about with glueRun-go even more than before. Because if an agent's behavior is changing through self-improvement loops, you can't just assume its execution traces are understandable. You need external validators, actual auditing systems, that can say, this change the agent made to its own harness, we approve it, or this one is too risky, revert.
But here's the counterpoint. Maybe this is exactly what's needed to scale parallel AI workflows without constant manual tuning. If you've got dozens of agents running on the same codebase, each one customizing itself to perform better on its specific class of problems, maybe that's more scalable than having humans manually tweak the harness for each agent every time something breaks.
True. You're trading interpretability for scalability. The cost of having humans understand every decision is that you can only run a handful of agents before the manual overhead becomes unmanageable. But if agents can improve their own rules, you can scale to dozens or hundreds of concurrent workers without the human overhead growing linearly.
So the real question becomes, how do you govern a system where you can't fully understand why every agent is behaving the way it is, but you need to be able to scale it? The answer seems to be, you build in multiple layers of audit and validation. You don't trust the agent to self-improve in isolation. You trust the system that validates the improvements.
Which brings us back to where we started this episode: governance and oversight. Whether it's Claude Tag in your Slack channels making decisions about what to prioritize, or glueRun-go agents rewriting their own rules to fix weaknesses, or self-harness systems optimizing their behavior, the pattern is the same. Powerful AI systems that are increasingly autonomous, increasingly embedded in critical workflows, and increasingly difficult for humans to fully understand. The question is whether the governance structures we're building, audit gates, audit logs, independent validation, are actually sufficient. Okay, I want to shift our thinking for a moment. We've been talking about how to build systems and infrastructure, but there's a more fundamental question about how humans should actually be interacting with AI. And I think the current model, where we ask AI a question and get an answer, is starting to feel obsolete. There's a concept called loops that changes how we think about this entirely.
Loops? You mean like feedback loops? Or something else?
Something else entirely. A prompt is one request. A loop is a recurring job with memory. So instead of asking Claude or Copilot a new question every time the same situation comes up, you define a recurring workflow that remembers what happened last time, learns from it, and gets smarter over time. And then a loop of loops is when multiple recurring workflows notice each other and hand off context.
Right, but what does that actually look like in practice? Because on the surface, it sounds like you're just automating things you'd normally do manually. But I'm guessing that's not quite the point?
Exactly. The key insight is that most meaningful work isn't a single question. It's a recurring situation that spans multiple apps and tools. You've got your email, your calendar, your project tracker, your code repository, and right now, you're the person who sits in the middle of all of that, carrying state in your head, noticing patterns, making connections. Loops are designed to sit in that gap, to do the wiring work you're currently doing manually.
So, give me an example. What's a loop that would actually be useful?
Say you're running multiple small projects, and you need to track research synthesis across AI developments. That's a recurring job that spans multiple sources: news, papers, Slack conversations. A loop would continuously scan those sources, pull out relevant signals, synthesize patterns, and surface them to you once a day or once a week. It handles what it can safely do, gathering and organizing information, asks when it needs your judgment, leaves records of what it found, and improves over time by learning from which signals actually matter to you.
So the loop is essentially delegating the routine work, the information gathering, the scanning, the organization, but it's smart enough to know when it needs to hand things off to a human for judgment. That's addressing a real problem. Because what you're describing is the stuff that lives in your head that you're constantly monitoring, constantly reevaluating.
Right. And the important part is that loops work asynchronously. You don't have to be constantly feeding it prompts. The loop runs on its own schedule, does its work, and only interrupts you when judgment actually matters. You allocate the effort once to build something that only wakes you when it matters.
And then, loops of loops. That's where it gets interesting for someone running a portfolio of multiple bets. Multiple loops notice each other and hand off context. So loop number 1 is monitoring research signals. Loop number 2 is tracking trading signal patterns. And if loop 1 discovers something that's relevant to loop 2, it hands that off without you having to connect the dots manually.
Exactly. That becomes an intelligent delegation system. You're not building one loop, you're building a network of loops that are paying attention to different things, noticing patterns in their own domain, and connecting to each other. And you only get woken up when there's something that requires your actual judgment. That's fundamentally different from checking multiple dashboards or running multiple prompts.
So the question for someone actually building this is, what loops are worth building? How do you know which recurring situations are safe enough to automate fully versus which ones need human judgment at every step?
There's a framework for thinking about it. Ask yourself, what state do I carry in my head right now? That's probably loop material. It's the stuff your brain is constantly tracking. Where do I check quality? That's where you put the human judgment gate. What's waiting on me? That tells you where loops should escalate rather than decide. And what changed since last pass? That helps you understand whether the loop's outputs are actually useful. If nothing ever changes, maybe you don't need the loop.
And the article emphasizes starting with things that are tedious but not critical. Not banking systems, not life or death decisions. Start with something where failure is recoverable, but success meaningfully reduces your cognitive load.
Exactly. You're learning how to build loops by doing it on lower stakes work. And then once you understand the pattern, how to define what the loop can safely handle, how to set quality gates, how to design the handoff to you, you can scale that to more complex situations. That's the shift from asking AI for answers to delegating recurring work to AI systems that improve over time.
All right, let's shift gears and talk about consumer hardware. Meta just announced something interesting on their product front. They've got Ray-Ban Meta glasses and Oakley Meta glasses starting at $299. Multiple styles, including Meta glasses by Kylie. Yes, Kylie Jenner has her own branded AR glasses through Meta. And they're also pushing the Quest 3S VR headset pretty aggressively. But here's what's remarkable. Every single one of these devices has Meta AI baked in. And the pricing and financing strategy is really designed to reduce friction.
$299 is actually accessible for smart glasses. That's not an expensive piece of hardware. That's entry-level consumer price point. But the financing part is what caught my eye. 0% APR and $19.99 per month. So you can get into Ray-Ban Meta glasses for basically $20 a month. That's an incredibly low-friction way to put AI-integrated eyewear on consumer faces at scale.
Right. And the distribution matters too. Meta is selling all of this directly through their consumer electronics store. Free 2-day delivery, 30-day returns policy. That removes all the friction that usually stops people from buying expensive hardware. You don't like them, you send them back. No questions asked. But here's the question I want to probe. Is Meta literally trying to own the eyeball as the primary interface for consumer AI? Because if you're wearing Meta glasses, your first instinct to access AI is through those glasses, not your phone or your laptop.
That's exactly what's happening. And they're being pretty explicit about it through the product positioning. There's athletic intelligence built into the Oakley Meta glasses, specifically for fitness and sports use cases. So it's not just generic AI glasses, they're segmenting the market. Kylie's branded version appeals to fashion-forward consumers, Oakley appeals to athletes, Ray-Ban appeals to the mainstream. But the thread running through all of them is, this is your primary interface to Meta AI. And the fact that they're integrating it into Slack, or trying to compete in the Slack layer like we discussed with Claude Tag, means they're not just selling hardware, they're trying to own the entire interaction layer from glasses to workspace collaboration tools.
But let me push back on something. Specialized AR hardware companies like Magic Leap have been trying this for years, and they've struggled. What makes Meta's play different? Why would Meta succeed where others have failed?
Distribution, data, and dumb competition. Meta has 2 billion users on Instagram, WhatsApp, and Facebook. They have ungodly amounts of data about how people actually interact with technology. They have a direct-to-consumer store with infrastructure already in place. And they have financing capabilities built in. Most importantly, they have a distribution advantage that Magic Leap or other specialized companies simply cannot match. When you've got that many users, that much data, and that much capital to absorb losses while you build the market, specialized competitors just can't compete on the same playing field. And frankly, Meta's already profitable. They can afford to iterate on glasses for years without needing every generation to make money.
So you're saying Meta's advantages in distribution and data scale basically make this unstoppable for any company that doesn't have their own 2 billion users? That's a sobering way to frame it.
Not unstoppable, but nearly impossible to outcompete on Meta's own terms. A specialized AR company would have to either find a niche that Meta doesn't care about, and good luck with that, or build a fundamentally better product that justifies the friction of a smaller distribution network. Right now, Meta is using price, financing, celebrity partnerships, and fitness positioning to create multiple entry ramps to the same hardware ecosystem. That's really smart portfolio thinking. They're not betting everything on one brand of glasses or one use case. They're betting on glasses as the primary interface and letting different products serve different customer segments.
Which connects directly back to what we've been talking about all episode, the embedding of AI into critical infrastructure. We discuss Claude Tag as the AI colonizing the collaboration layer in Slack. Meta is doing something similar, but at the consumer level. They're colonizing the eyeball. Your glasses are your interface to Meta AI, which means your experience of AI is mediated by Meta's choices about what features to ship, what data to collect, what to optimize for. And like we talked about with governance, who's overseeing that?
So we've covered a lot of AI infrastructure today. Corporate players racing to embed AI deeper into how we work, security vulnerabilities in tools people are betting on, agents that can rewrite their own rules. But there's another move happening right now that's worth paying attention to. The UK government just announced 2 new AI research labs with up to £60 million in funding, SOFARE at UCL and BOLD at Oxford. And the framing here is pretty explicit. This is not about trying to outcompute Silicon Valley. This is about building fundamentally different infrastructure.
Okay, I'm curious because we've seen governments fund AI research before, and it usually doesn't move the needle much. What makes this different? What's the actual strategic intent behind these labs?
That's the key question. Most government AI research tends to either fund research that's interesting academically but not practically useful, or it plays catch-up to what big tech is already doing. These labs are explicitly positioning themselves to do something different. SOFARE Lab at UCL is focused on creating open-source AI that runs on widely available hardware, not enterprise data centers with massive GPU clusters, not cloud infrastructure that costs thousands of dollars a month, hardware that normal people and small organizations actually have access to.
So they're not trying to build ChatGPT-level models that require a fortune in compute. They're trying to build useful AI systems that can run on, what, a laptop? A standard desktop machine?
Exactly. That's the SOFARE angle. But there's also BOLD Lab at Oxford, which is attacking the problem from a different direction. BOLD is focused on efficient learning systems, fundamentally new ways to build AI that can adapt and improve without requiring vast centralized compute infrastructure. So instead of how do we make open-source versions of large models that already exist, BOLD is asking, what does AI architecture look like if you're not trying to throw a billion parameters at every problem?
Right, so you've got two complementary strategies. SOFARE is making existing approaches more accessible. BOLD is actually researching alternatives to the current paradigm. That's a more interesting bet than I initially thought. But let me push on the strategic framing. Why is the UK government making this bet right now? What's the logic?
The explicit logic is this. The UK is not going to win a compute spending arms race against OpenAI, Google, and Anthropic. Those companies have venture funding, massive data advantages, and established infrastructure. The UK doesn't have that scale. What the UK does have is academic research excellence and the ability to invest in long-term fundamental innovation. So instead of saying, we're going to build bigger models than Google, they're saying, we're going to fundamentally change how AI gets built. That's research innovation as a differentiator.
And there's a talent pipeline component too, right? Because if you just fund labs and expect results, you also need people who can actually do the work.
Yes. £2 million per lab for 10 doctoral students. So you're not just funding research, you're building a generation of UK-based AI researchers who are trained in efficient systems and accessible infrastructure rather than in scaling massive centralized models. That creates long-term competitive advantage. These PhD students become the researchers who shape AI infrastructure for the next decade. They're not trained in the throw more compute at it paradigm that dominates US tech. They're trained in the build with constraint paradigm.
But here's the tension I'm sitting with. Academic research is slow. Government funding processes are slow. Meanwhile, OpenAI just released a new model. Anthropic is shipping Claude tag. These labs might do interesting work, but by the time SOFARE or BOLD publish something practically useful, the frontier will have moved on again. How does academic research actually compete with that pace?
That's a fair challenge, and it's real. Academic research does move slower, but I think the framing might be wrong. These labs probably aren't trying to beat OpenAI at releasing the next best model. They're trying to solve a different problem. How do you build AI infrastructure that doesn't require you to be OpenAI? If BOLD actually cracks efficient learning systems that work well on consumer hardware, that's not competing with frontier models. That's making AI accessible to everyone else. and practically, that might matter more than who has the coolest model.
So you're describing a scenario where the question isn't, will SoFair or Bold out-research OpenAI, but rather, can these labs create tools and approaches that make it so you don't need OpenAI in the first place? That's a different game. But does that actually happen? Or do open source alternatives to proprietary models tend to just be inferior versions that people reluctantly use because they're free?
Sometimes. But there are counterexamples. Llama, which Meta open-sourced, became the foundation for an enormous ecosystem of smaller models and fine-tuned versions. That happened not because Llama was better than GPT-4, but because it was accessible enough that thousands of researchers and builders could build on it. If Bold comes up with a fundamentally more efficient approach to building AI systems, that could unlock a similar dynamic. Suddenly, there's a path for smaller organizations and different countries to build capable AI systems without being dependent on 3 companies in Silicon Valley.
Which brings me to the broader question underneath this announcement. Why is the UK government making this bet now? What does it signal about how governments are thinking about AI centralization? Because the implicit message is, we're concerned that AI power is concentrating in a handful of companies, and that creates economic and political risks we need to address.
That's exactly it. Right now, the frontier of AI is controlled by maybe 3 to 5 companies: OpenAI, Google, Anthropic, maybe Meta. Every government that cares about technological sovereignty has to be asking, what happens if we become dependent on those companies for critical infrastructure? What if they decide to restrict access? What if they prioritize US interests over ours? The UK announcement is saying, implicitly, that the current centralization path is unacceptable. They're not saying they can compete head-to-head. They're saying they're going to fund an alternative.
And we've seen this movie before. When the internet was emerging, governments realized they couldn't leave it entirely to commercial providers. They funded basic research that became the foundation for resilient, distributed internet architecture. This feels like the UK saying, we need similar infrastructure for AI, not to avoid using frontier models, but to make sure we have optionality if we need it.
Exactly. The labs aren't necessarily saying, use our AI instead of GPT-4. They're saying, we're going to make sure there are viable alternatives if the frontier gets too concentrated or too expensive or too dependent on US companies. That's actually a pretty rational government response to the current moment. Whether it works, whether academic research actually produces practically useful alternatives to proprietary models, that's an open question. But at least they're asking the right question.
So we've covered 9 stories today, and there's a thread running through all of them that I think is worth pulling. We're watching AI develop at an incredible pace. Anthropic shipping Claude tag, Meta shipping glasses, researchers building agents that can rewrite their own rules, but at the same exact time, we're discovering security vulnerabilities in the infrastructure that companies are betting their businesses on. And we're having conversations about how to govern moral choices embedded in AI systems. The problem is, the speed at which AI is moving is not the same as the speed at which governance, security auditing, or regulatory frameworks can move.
Right. And the practical consequence of that mismatch is that decisions are being made, serious decisions about borders, mortgages, weapons targeting, before we've even agreed as societies what the standards should be. We're building the aircraft while it's flying, and what's particularly striking is that the companies building it are the ones setting the standards. You've got Claude code returning encrypted reasoning blocks that hide what the model is actually doing, and Anthropic gets to decide what extended thinking means and how transparent it really is. That's not governance, that's trust me.
But here's where it gets interesting. We're also seeing countermoves. The UK is funding labs explicitly designed to democratize AI infrastructure instead of concentrating it further. We've got open source frameworks like glueRun-go that let smaller teams orchestrate agents without needing to build everything from scratch. We're seeing research on self-improving harnesses and loop-based delegation systems that might actually make it possible for solo builders to do what used to require teams. So the narrative isn't just AI is accelerating and governance is falling behind. The narrative is also some people are building alternatives.
Which brings us to what this actually means for someone trying to build an AI-assisted business right now. The lesson is paradoxical. Move fast, because standards are still forming and the window for launching before regulation locks things down is real. But move fast on architectures that won't become illegal or obsolete the moment oversight catches up. Don't build on top of proprietary encryption that's going to fail cryptographic auditing. Don't build systems that are so dependent on one company's API that a change in their business model breaks your entire product. Build for optionality. That's the practical synthesis.
Because the underlying dynamic is that power is being concentrated. Claude Tag colonizing the collaboration layer, Meta colonizing the eyeball as the primary interface to AI, 3 companies controlling the frontier models, and the question that connects all of this is actually a question about human agency. If agents start rewriting their own rules to improve their performance, making decisions that humans can't fully understand, embedding themselves into critical parts of how we work and live, what does human agency even mean in that world? We're not asking whether AI should be regulated. We're asking whether humans will retain the ability to make meaningful choices about how AI operates.
That's the meta question underneath every story we covered today. And honestly, the answer probably isn't governance will fix it or markets will fix it. The answer is probably some combination. We build governance structures and oversight mechanisms, but we also decentralize the infrastructure so that no single company or government controls the tools that everyone depends on. The UK labs are a bet on that. Open source models are a bet on that. Framework like glueRun-go that lets smaller teams run autonomous agents are a bet on that. It's not preventing AI from moving fast, it's making sure that when it moves fast, it doesn't move in one direction controlled by one entity.
And that's where we land. Thanks for joining us for the Daily News Update. Today we saw AI companies racing to embed AI deeper into critical infrastructure, security vulnerabilities in the tools they're deploying, researchers building agents that improve themselves, and governments trying to fund alternatives to concentration. The pace is accelerating, the stakes are enormous, and the question of who controls that pace, who sets the standards, and what human agency means in a world of autonomous AI systems, that's the conversation happening right now. That's the story underneath every story we covered. Thanks for sticking with us.